start doing some more cool stuff with nodes and relative references. So I'm going to start over, make another box, and we'll go down inside of that. And so to scale all of the sizes of the box, we could just use the uniform scale, but because we're going over relative referencing, I want to show you how to do that using just one size reference. So we can copy this X size parameter and paste it, the relative reference over here, and again in the Z. And then when we scale this, we get the same effect as our uniform scale factor. So let's go ahead and copy this parameter and paste its relative reference. And sometimes writing expressions and stuff in here for simple things like this can be hard to see. Me, for example, I'm colorblind, and side effects chose to have orange and red text on a green background. So for me, it's awfully hard to see where my cursor is. So if you hit Alt-E, it will bring up a edit expression window, and this is on a black background, which is much easier for color impaired people like me to read. So here we're just going to multiply this by 0.5, hit apply and accept, and now our cube will grow from the base of the grid. So I'm going to go down here and add a color node. Let's back out of that. And let's make this a blue color, just to help differentiate some of the shapes that we're going to go through. And let's look at another possible way to make a box. So let's start with a grid and display that. And now on our grid is a similar X and Y size. It has no Z height. So what we can do is go to our box node and copy its size parameter and just paste it right here and right here. And now if we template our box on the grid, we can see that our grid, when our box scales, our grid will scale just the same. Let's see about how to control these divisions to increase with the scale of our grid. So to do that, we can just copy this and we'll paste it here. And we'll notice it disappears because a grid has to have at least 2 rows and 2 columns in order to be a grid. If we turn points on, we'll see that now, because we only have 1 row, we just have a line with 10 points on it. So we're going to have to hit +1. And now we have 1 row with 10 columns. And we'll go ahead and copy that and paste this so that our rows always match our number of columns. And then we'll see as this grows, our grid will subdivide as the box grows. But right now this is just a grid, not a box. So let's poly extrude this. And we'll increase the distance of the poly extrude. And let's go ahead and say we want this to always be the same size as the box. So let's copy this box's height parameter and we'll paste it onto our distance. And now it will be the same as a cube. And we need these divisions here so we can actually increase the number of divisions on our poly extrude as it goes. So we need this to be the same number of divisions as our rows and columns. So we can go ahead and copy that, and we'll paste that here. And so now as our grid grows in size and our box grows, it will add more and more divisions for us. So something when working with poly extrude that you need to be aware of is poly extrude takes the face and moves it up and generates sides along the extrusion point. So when we actually look at the bottom of this, let's hide this grid, we'll see that there is no bottom. And to do this, we'll show the point normals, and all of these faces are pointing outward. So what we can do to put the bottom on here is if we scroll down in our poly extrude, we can see output geometry in groups, and we'll just tell it to output back. And now we have a closed cube shape at the bottom. Point normals off, and let's go ahead and make this shape red color. And we'll make this some kind of red shape color. Alright. And box this, call this blue box. I'll call this red box. And now let's start looking at working with some points or curves. So let's start with a curve, and we'll highlight it, make this displayed, and let's turn my grid back on. And when working with curves and some similar nodes, they need to be activated before we can mess with them. We could manually type coordinates in here, or we could go into the scene view and press enter, and then start left clicking around on the grid and let's put down 4 points because that's 4 sides in a square, and we'll close this shape. And now we have a plane, but it's floating. So what we could do is add a transform node and just scale this down to 0. But then it's not really a square or anything like that. And another thing that we could do if we start a new curve is we could turn on grid snapping. If we put this on, we can also toggle this on and off with X, and it will bring up a radial menu here, and we can choose what we want to snap points to. And with grid snapping turned on, when we actually left click, you can see it will start snapping and highlighting points on the grid. So in this case, we can do this, and it will snap our 4 points to the grid. We can close it, and then we'll have a nice box here. So doing this is well and good, but it makes working with points on curves like this makes it hard to control all of these individual points with this value. Notice doing it this way could be quite a pain. So instead of using just a curve, we can use the add node, which allows us to add points one at a time in a specific order. So let's add a couple points, 4 points total. We'll turn this point on. Our first point is going to be at 0, 0, 0. We'll start it at the origin. The next point will be at 0 and the size of this here. So we don't need anything in Y. Do that. Let's display point numbers to make this easier to see. We'll put this guy here, and then on the 4th point, do that and that. Actually, let's do this, and then we'll right click and delete this channel and change this back to 0. Now I have 0, 1, 2, 3. Display points to make that easier to see. And now once we've added our 4 points, if we go over to polygons and we combine polygons by group and close the shape, we'll get another grid right here. And now, if we template our box, as we scale our box, it will likewise scale here. We can just add a transform, and we'll translate it by negative 0.5 of the distance of that, and then we'll copy this and paste this in here, and that way it will always line up in the center to our box. Another way to do this actually would be to, let's make another transform node, and going in here, instead we can transform this by half of its maximum x distance and half of its maximum z or z distance. So in order to do this, we can start typing an expression in here. And we'll do negative $sign to start using a predefined variable, and we'll type x max, and you'll notice this list will come up, and we'll go down to select x max and hit enter, and then multiply this by 0.5. And when we shrink this, and we'll see that it has offset our box, our closed curve shape square, by half of its distance. Similarly, we can go here and do negative $z max times 0.5. And we'll center right there. Now, I want to point out something with the add node and the direction that points are drawn on a curve. You'll notice that on this add node, we drew the points going clockwise, that is 0, 1, 2, 3 from left to right. If I make another add node, and let's make 4 points, and this time we're going to go 0, 1, 2, 3. So let's go ahead and go back to our box and copy this parameter, and we're going to paste it here. So 3 is up there, put 0.2 over in that corner, and then we'll put 3 up over here, or 0.1 over here. Alright, so now when we go to polygons and we by group and close the shape, notice our normal is actually pointing down in this case. So when you're drawing curves, keep in mind the direction that you were drawing your placing your points, because clockwise will go up and counterclockwise will go down. This is actually, I believe, opposite from how most other programs perform this operation. So keep that in mind when you're creating curves. So when you do something like this, instead of having to go and redraw our curve, what we can do is instead add a reverse node, and it will flip our node bigger. Let's go ahead and make that normal scale a bit bigger. Yeah, that's much easier to see. And now that we've gotten that, we're going to go ahead and copy and paste this transform node down over here so we can get it centered again. And let's just delete this guy, and we'll go ahead and add another color node, and we'll make this one yellow, and add a color node, and we'll make this one limited on color options, he'll be dark gray. take a look at how to switch between our different boxes. So what we can do in this case is just drag off this one and type switch, and then we can drag all of these together. If we wanted to see them all at one time together, we could merge them all and view them one at a time. But the switch node will allow us to view one at a time based off of an input. So here we can see that the bold line, or the solid line, is what input our switch node is currently outputting. The dotted lines are not currently being used. We can change that input by just cycling through on our switch node to change which output we're viewing. So now that we've got that going, let's go ahead and finish making these add nodes more box-like, as it were. So the cool thing about Houdini is once we have the basic shape up here, we can switch between them and perform operations further down the line. So let's go ahead and add another switch node up here, and we'll go ahead and feed these in here. Let's break this. All right. We'll call this yellow box, and we'll call this gray box. So with our switch node, we can go ahead and put down a poly extrude below that, and we're coming from the left, or 0 input right here. And on this poly extrude, we're going to want to have it extrude by the distance of our box again. So let's copy that parameter, go to the poly extrude, and paste that reference. And now as we switch through, both boxes will poly extrude by the same amount as our original box 1. But again, we can't forget about adding that output back to close up the bottom of the box. So we could use the poly extrude to add divisions here, but we could also add divisions in another way using something called the poly split node. So what the poly split does is it allows us to physically place edge loops on our geometry. So we're going to go ahead and select edge loop for path type and just choose the number of loops to add, and we'll just hit enter and click there, and it has added another edge loop to our geometry. In Houdini, we can repeat the last command that we used by pressing Q, and it will create another poly split node. And we'll go ahead and change this to edge loop again, and one loop. And we'll sit there, and it has made another edge loop for us. And I'm going to go ahead and do that again one more time. Here. And we'll go ahead and move this into that switch, and we'll break this one. So sometimes when we get stuff like this, our layout can get a little bit messed up, and we can fix that pretty easily by just pressing L, and it will lay out our node network in the way that Houdini thinks is best. Another way you can do this is, say I want my switch node over here or down here, but these guys are still messed up over here. What I can do is select the guys that I want to lay out, and then hit Shift L, and it will lay just those nodes out and leave the rest of my tree or my network intact. In future videos, we'll be going more over the switch node and how we can use expressions to naturally control which input operation we're seeing. Let's go ahead and display that node. But for right now, let's move on and look at some more interactions that we can do with some geometry nodes. So, let's take a look at group nodes. So we're going to tab and make a group. And what this group node will do is allow us to procedurally select specific parts of a piece of geometry to perform operations on down the line. So what we can do in this case with our group is unselect base group, which will by default select all of the primitives in the geometry based upon our group types. We can select primitives, points, or edges. In this case, we'll be selecting primitives. And we could do this in a couple of ways. Something that we can do is by just displaying the primitive number. Let's say I want to select the top primitive, so that would be point face 5. Let's go ahead and make that a little bit bigger. It's probably easier for you guys to see. So I can hit 5, and it will select primitive 5 from my group. I'm going to go ahead and change my group name to top bases. Something to be aware of is groups do not like spaces, so in the case where you want to have multiple words, you'll notice I get this little warning in here, and it'll say top face is not a valid name for a group. So either do some form of camel case or use the underscore to add spaces, as it were, to your group names. Using this group, what we can do, rather than hard coding which face we want, because let's take a look at what happens if we change our switch. Right now our group is selecting the 5th primitive face on our geometry. But if we change our group, notice we now have a lot more primitives, and it's still going to try to select primitive 5. Just like we move this over, primitive 5 is now in a different location every time. This does work if you can guarantee in every situation that your primitive is always going to stay primitive 5, and that it will never change. But in our case, that doesn't really work for what we're trying to do. So what we can do instead is group by normal direction. So in this instance, we want to group all primitives that are having normals facing up in the Y direction. So we can do that by removing our base group and saying keep by normals. And here we're going to group by Y, and this is a range of 0 to 1, so 1 being all the way up and 0 being all the way not up. And spread angle, you'll see as I lower this down, it will at 180 select a 180 degree difference from the normal direction that we have chosen. As I move this down below 180, it will only select things from 124 or so, and as this drops below 90, you'll see it will break off and only select that because we have 90 degree angle breaks between our normals. So to make absolutely sure that we only select the upward facing normals, we'll make our spread angle 0, and then it will only select normals whose normal direction is absolutely vertical in the Y direction. And now, when we go back and move through our switch, you'll see that it is highlighting all of the normals that are facing up. Notice our switch actually only has 3 inputs, but we have 4 up here. So let's handle that real quick. What we can do for that case is link this switch node to this switch node. So we can actually copy this switch's input over to this one, and we'll paste that right here. And now when this switch changes, it's not going to do exactly what we want, and that is because we're asking this switch node, if we look over here, index out of range, not a valid source. So we're telling this switch node to find on a range of starting at 0, so 0, 1, 2, so a third input here. And there is nothing there, so it's going to use the one closest to that value, which in this case is 1. So what we can do to make sure that those line up is add a couple null nodes to the front of our switch. And we can rearrange our null nodes to the top by just setting these arrows and moving them up. And now you'll notice that on 0 and 1, this switch will display nothing, but on 2 and 3, it will display the correct values. And then if we step down to our switch down here, we'll have to link a fourth input into here to make sure that the switch numbers line up again. We'll get all 4 of our values now. So now that we are correctly selecting the top primitives from all 4 of our different shapes, let's go ahead and perform some operations on those top primitives. So I'm going to hit blast, so it will blast away all of the geometry that is above it. Or, in our case, we want to blast away only the geometry that is in our top face group. So what we can do is click this little drop down arrow and select top face from this selection, and you'll notice that it has deleted the top faces of our primitive selection. And it will do that for all 4 of our inputs. Rather than hitting this drop down arrow, what we could do is instead just simply type top face, and it will work just the same. And we can use these operations all the way down and continue working as we would as if we had one input. So in this example, we'll just add another poly extrude. And we'll just scale this in and make sure to output those back faces. And we've got our nifty little box. And then we'll drop a output node at the end. And there we go. That's a quick overview on how to use relative referencing and some simple geometry nodes to make a simple geometric shape in Houdini.